All right, my friends, let us begin the 2008 AP Calculus question. All right, so this is calculator active. As you can see, we need to find the area of region R. And just like in the previous problem that we kind of went over, remember, if you want to find the area, it's just top curve minus bottom curve. Now, the only thing we need to know is we need to know which one is which, right? Which one of these is sine of x? Which one of these is the x to the third, or sine of pi x, right? Well, that's why you have a handy dandy calculator. You know, you go to hit on. Okay, and we're gonna hit y equals, plug them into here, and look at my bounds, right? I'm gonna go to window. I'm gonna change it just to this graph. So it's from 0 to 2. This is my x values, and my y values are from I guess I'll put y minimum negative 3.5, just so I can get an image of up and above, and my y maximum I'll put at 1.5, right? I just want to be able to get a visual image. So I got that there. Bam. I'm going to go ahead and hit graph. So the first one is obviously sine, because I put that in first, and the second one is obviously x to the third. So just graphing that through, changing the bounds, leads me to believe we know now this is sine of pi x, and this is x to the third minus 4x. All right, find the area of R. Well, my friends, that's just top curve minus bottom curve. No need to find any points of intersection, so we're going to get sine of pi x subtracted by parentheses x to the third minus 4x. Boom, boom, dx. Bam. We just use our calculator, and if you plug that all in, you remember you could do y1 minus y2. We get this to be equal to 4. Believe it or not, we actually get a nice answer. And that right there, my friends, is 3 points. 3 points for that problem. All right, on to the next one. The horizontal line y equals negative 2. So y equals negative 2. I'll go ahead and draw that. Splits the region R into two parts, right? But do not evaluate an integral expression for the area of part R that is below this horizontal line. So what we want to do is find this area right there. Okay. Boom. Well, I think one of the things that we are so accustomed to is we are so accustomed to doing radiuses right down below this region. We just want to find the area. We're not doing any radiuses or anything like that. And remember, when usually we get a negative value, we do a little bit of work, right? We go, boom, we make our big R, little r, but we're not doing volume in terms of a rotation. We're finding the area. And what's area? If I want to find the area of, again, this part in here, what do? Well, it's top curve minus bottom curve. So when it's area, we just do exactly what we've always done. It's from, well, we got to find these points of intersections now. That's the only thing that's different, is we're starting here and we're starting here. Okay. Bam, let me go ahead and mark them down here. We're starting there. So if I go ahead and go to my calculator, I'll go ahead and hit y equals, let me go down to y3 and hit negative 2, right? That's the y value I'm interested in, and I'm going to find these points of intersection. So second trace, go to intersect, hit enter. I have my 4 arrows here. I'm going to hit the down arrow to put me down on the lower one. First curve, I just want to make sure that I'm on one curve. Second curve, I'm on the second curve, obviously. And now I'll go ahead and guess. Boom, boom, boom. And we get that the point of intersection is 0.53. So 0.5391889. All right, I'm going to write the entire thing, and if I do the same process, I'll get 1.67513009, right? These points right there, and I want to write all the decimals that I can. Make sure you want to write the exact values. So here I'm writing down the exact values that I can get here. Beautiful. Top curve. Well, what's your top curve? Well, top curve is just negative 2 subtracted by your bottom curve, which is just x to the 3 minus 4x. Boom. Put an extra set of parentheses, but bada blah dx, and then we're done. Now we just plug that into the calculator. And we're good. And what is this area? The area between this? Well, actually, I'm not sure, and I don't want to spend time doing it. You obviously got a calculator. Oh, never mind. Right, but do not evaluate an integral expression. Oh, so we're good. There it is. Bam, we're done. This is 2 points. So now we're at 5 out of 9 points, and we're sitting pretty excited. So, on to the next problem. The region R for this base of a solid. The region R is the base of a solid. For this solid, each cross section perpendicular to the x-axis is a square. Find the volume of the solid. So we pretty much have, we talked about this before. We have, not the best drawing in the world. We have a square in here. Boom, this is a square, right? And we know the base of a solid is a square and it's perpendicular to the x-axis, so we're all good. And we basically want to find the volume of this. Well, we know the area of a square is L squared, length times length, because these sides are the same. So our job is to find the length. Well, it's just top curve minus bottom curve. Top curve minus bottom curve. Boom. And that is going to be my length. And so now I just do the integral and I'll set it up. In the previous video, I self-corrected myself. And what I mean by that is I know I did this. I put down this right here. And I forgot, again, this is the cross sections is a square. I forgot to put the square on the top, and I did put the notes on the video for that. Boom, there it is. Top curve minus bottom curve. This is the area of a square. No need to put a pi. Plug this into your calculator because it says to find the volume. That means we actually want to. And if you do that, you'll get 8.370. And that kind of concludes this video here. Part D is a little more challenging, especially because it's talking about the region R models the surface of a pond. At all the points in R at a distance x from the y-axis, the depth of the water is given by that. Find the volume of the water. So what's kind of hard about this is that it involves depth, which makes it three-dimensional. So really what we have is a little depth here. Right around this is kind of like the depth of water, and they're telling us this length here is your depth, and then we have this base here, and it's just a little complicated, and I honestly just rather avoid that right now. If you're really interested, we can go over it after school, but for now I'd rather focus on the kind of the problems that I feel really good that we could really try to get. All right, take